In this video, we wish to determine the pH and pOH of 0.1 molar hydrochloric acid. And of course, we are required to determine the concentration of hydroxyl ion in this solution. So how do we approach this problem? It's indeed a simple one. From the question here, we are to determine pH, we don't know. So pH we don't know. Also pOH we do not know. But we know the concentration of the HCl given there. Please, I'd like to state that this concentration 0.1 molar HCl represents the concentration of hydrogen ion. The reason being that this HCl is an acid. I know that according to Arrhenius, an acid is measured based on its tendency to give out hydrogen ion in a solution. Is that not so? So whenever you hear concentration of an acid, in terms of calculating pH, that concentration represents the concentration of the hydrogen ion. Is that clear? So I'm going to write concentration of hydrogen ion is equal to 0.1 molar. This 0.1 molar simply means moles per either dm cube or per liter. Alright. Having done that, the next question there we are to determine the concentration of hydroxyl ion. We don't know. So we're going to apply the knowledge of what we've learned so far on the pH and pOH to determine the value of the pH and pOH of this acid, and as well proceed to determine the hydroxyl ion concentration. So I'm going to write recall. Let me use blue marker to write the formula, okay? So we have to recall that pH is equal to negative log to base 10 of hydrogen ion concentration. So that's the formula for pH. So we can now substitute directly to get the pH value of this HCl. The pH will be negative log 10. Hydrogen ion concentration is 0.1 molar. Alright, so log to base 10. We're going to find out the value of this. Of course, this is going to be 1. You can use logarithm law if you don't want to press a calculator. If you don't want to press the calculator, 0.1 is the same as 1 times 10 raised to the power minus 1. Then apply negative law of indices. Guess I should do that right. Let's see. So this is going to give us minus log. This is 10 raised to the power minus 1, then base 10. If you work in this, we're going to get, according to Power law of logarithm, if a number, log of a number, that number is raised to the power, you can use that power to multiply the log. So this is going to give you minus 1 times minus log 10 to base 10. And we know that log of any number to the same base is equal to 1. You write that, but log 10 to base 10 is equal to 1 from the knowledge of logarithm. So it means that our pH is equal to minus 1 times minus 1 in bracket. Where is minus 1? Minus, look at it, the full come minus from the formula of pH, and then log 10 to base 10 is equal to 1 already, so you fix the 1 there. In conclusion, therefore, pH of this acid is 1. That's the value of the pH. Okay, so we can proceed to determine the pOH now of HCl. So that's the second part of the question. Now to obtain pOH, now we can actually get pOH from negative logarithm to base 10 of hydroxyl ion concentration. But we don't know the hydroxyl ion concentration here. Therefore, what do? We have to recall that pH plus pOH. Let me put answer here. I'm done with the first part for pH. I'm going to write recall pOH plus pH is equal to 14. We derived this through the ionic product of water. That being the case, we're looking for pOH, is now going to be equal to 14 minus the value of pH we got, which is 1. And you see that this pOH value is going to be 13. So that's the value of the pOH answer. The last part now, we have to determine the hydroxyl ion concentration. So again, I will write recall that hydroxyl ion concentration, which we have the formula to be this hydroxyl ion concentration is equal to 10 to the power of negative pOH. So the hydroxyl ion concentration of this solution is going to be 10 to the power of minus 13. Alright, 10 to the power of minus 13, which is there about 0.00000, 13 zeros, before 1. Oh my god, that tells you how small the hydroxyl ion concentration of hydrochloric acid is, which is why we neglect the fact that there is a basic level, in this acid. We could just call it an acid, hydrochloric acid, because the concentration of what could have made this a base, the concentration is extremely low, very, very low. You could see that. Like I said, in fact, let me write it. Or, gonna do something here. We could say that concentration of the hydroxyl ion is equal to what will happen now? 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've gotten 13 zeros. So 1 molar. Very small. Is that also? Let me indicate very, very small. Which is why this is taken as an acid. In this video, we have this question where we are required to find the pH, to find the hydrogen ion concentration of a given 0.5 molar sodium hydroxide. Now, this problem is similar to what we saw in question number 1 for hydrochloric acid. The only difference is for that question number 1, the solution given to us there was hydrochloric acid, but in this case, the solution given to us is a base, sodium hydroxide, which simply tells us that this concentration given 0.5 molar is hydroxyl ion concentration, because hydroxyl defines what? A base for us. Alright, let me bring out the information given to us. From the question, I've just explained that concentration given there is hydroxyl ion concentration, and the value is 0.5 molar. Is that okay? And on the first part of the question, we are required to obtain the value of pH. We do not know. So let us solve for that pH first. But of course, we cannot get the pH of a base from hydroxyl ion concentration. I hope you know pH directly defines something about an acid, whose base formula, the basic formula of pH is negative log to base 10 of hydrogen ion concentration. But what was given to us in the question here is not hydrogen ion concentration. So how can we actually get the pH of this? This is a base. We're talking about pH of a base instead of pOH. You see? But of course, a question of this kind is possible, just like you will see us solve it. That is why this equation, pH plus pOH equal to 14, is very unique. Of course, that is what we're going to do. So I would say recall. I've told you why I cannot use the basic formula of pH to solve this problem. That is minus log to base 10 of hydrogen ion concentration. I didn't know hydrogen ion concentration from the question. I didn't know it. What was given to me is hydroxyl ion concentration. So the other way I can approach this problem is recalling that pH plus pOH will be equal to 14, which implies that pH of this sodium hydroxide will be 14 minus pOH of that sodium hydroxide. So you see clearly that we need to obtain, we need to get pOH first. And good enough, we have the hydroxyl ion concentration, so we can actually get the value of pOH. Before then, let me take note of this equation. Let me call this equation alpha, because I'll substitute into it once I get my pOH. You can say then that recall again, okay, that pOH, which I need to get first, is negative log to base 10 of hydroxyl ion concentration. Good enough from the question, I know the hydroxyl ion concentration. So I would substitute directly. pOH will be negative log of the hydroxyl ion concentration, which is 0.5 molar to base 10. So what's going to be the value of pOH for us? So pOH will now be equal to, I'm going to seek for my calculator this time around. So this is going to be negative log of 0.5. Right, the calculator gave me 0.3. I'm picking just one decimal as the pOH of this sodium hydroxide. But of course, it is not pOH I'm calculating. So let me just wipe off this line I drew. What I'm looking for is pH. So what I will now write, I will then say you should substitute for pOH in equation alpha. So that's going to give us that pH is equal to 14. We are subtracting pOH from it. And then pH is equal to, if you do 14 minus 0.3, so this is going to give us 13.7. This is the pH value, and so this is the pH value of that sodium hydroxide, while the pOH value is 0.3. Now let us calculate next the hydrogen ion concentration in this sodium hydroxide. You know, sodium hydroxide is a base. So we want to see the level of hydrogen ion inside this base, which gives that base a little acid property. Does that make sense? So we're going to move on to the second part of the question. We are required to obtain the concentration of hydrogen ion. We don't know. At this point, we've obtained pH value. You know that pH is linked to hydrogen ion concentration, just like pOH is linked to hydroxyl ion concentration. So this, I'm going to recall that we established that hydrogen ion concentration can be obtained from pH. All you need to do is 10 to the power of pH. So the hydrogen ion concentration in this case is not going to give us 10 to the power of negative 13.7, because our pH is 13.7 for this sodium hydroxide. Then the concentration of the hydrogen ion is now going to give us 10 to the power of negative 13.7. We would see how very small this is going to be, simply because this is a base. The acidic level will be very low. Okay, so 13.7, let's see what this gives to me. Wow, this is 1.99, approximately 2 times 10 to the power of minus 14. Do you see how very small this value is? Once again, let me write that. And this is the answer. I could still say or. This value, 14 zeros before you meet these two. So we go. So we can say that the concentration of hydrogen ion here is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I've gotten 14 zeros, so I'll put these two here now. It becomes molar. I've written this standard form number in decimal form or ordinary form. So do you see very, very small? I'm going to indicate that extremely small. Extremely small. And of course, that is why this is a base, not an acid. But it does not mean that it doesn't contain any amount of hydrogen ion. It does contain, but it is very small, that we could neglect it, that there is no acidic level in it.